Hello viewers of the Mobile Science Laboratory experiments. Today the Mobile Science Laboratory is very happy to invite Professor Sai Prakash, my childhood friend, my schoolmate, my college mate and my guru, because I have done my PhD under him. Sai, welcome to Mobile Science Laboratory.
Thank you so
and
much.
Thank you for gracing us with your presence. Today the experiment that we are going to do is called a clock reaction. Now, what is a clock reaction? It is a reaction which can be timed with a clock. Isn't that better?
Fine,
I think that's better. So, what we will do is we have taken two solutions. One is called potassium persulfate, as you can see over here. It is a colorless solution. And the other one is potassium iodide, which is another colorless solution. Now, the moment you add these two, you will see some reaction. But to help us to make this simple reaction into a clock reaction, we want to slow down the reaction a little bit so that we can time it with the help of this particular stop clock. So that is why this reaction is called an iodine clock reaction. So Sai,
Started?
how would you like to start this reaction?
We first do the experiment directly.
All right.
Here we have this beaker.
Yes.
Take about 20 ml roughly. You can use a test tube and take half of it.
I am going to take a test tube and I am going to fill it up with persulfate solution.
Half the volume should be all right.
This is enough?
That's
All
fine.
right.
That's fine.
So, shall I pour it into
Pour
it?
it into it. Then what you do is,
Yes.
you take the sodium thiosulfate, about 5 ml.
Sodium thiosulfate, you want 5 ml of that.
Roughly.
So that means I take another test tube and I will just put about,
Half of what we have done earlier. Some more.
this is enough?
Little bit.
A little bit more.
And the concentration of hypo is very low. Right? If you take about m by 20 of persulfate and m by 20 of iodide, this will be m by 200. There is a reason for it, why the concentration is so low. Now, we add this to it.
Shall I add this into this?
So, here we have potassium persulfate and hypo is sodium thiosulfate. Okay. Next, a starch is to be added.
Starch. This is a solution of starch. Students, you must always remember, starch is a very specific indicator for iodine. The moment iodine reacts with starch, it gives a blue color. And starch is one indicator which you use in not in drops but in ml. So I am going to just add a few without measuring it. Okay. I think that should be enough.
All right. Now, so in this, what all we have? Potassium persulfate.
Potassium persulfate is there.
Sodium thiosulfate.
Sodium thiosulfate is there.
Starch.
Starch is there.
The only one to be added now is potassium iodide.
Okay.
Take it in there.
The same quantity.
Same quantity as you have taken for persulfate.
Right. So I am taking potassium iodide solution, as you can see over here,
Right.
almost the same quantity as potassium persulfate.
You control that.
And now, when Professor adds this into it, I will start my reaction and I will hold the stop.
Ready?
Ready?
Keep watching. That's a color. Okay. This is a starch iodine complex, characteristic color, and it has come after how many seconds? 60 plus.
It has come to almost 61 seconds.
Oh God. That's
61
an excellent timing.
seconds.
That's an excellent timing.
This is a very nice timing for a clock reaction, about 1 minute reaction. And how do we know the reaction is over? By the sudden appearance of that dark blue color.
Okay.
So what I am going to do is, I am going to add some more hypo into this. Now students, keep watching this. We have made the color go away by adding some sodium thiosulfate, which is commonly called hypo in common language. Now, when we have added hypo, the blue color has disappeared. If we wait for some more time, you will find the appearance of blue color again. Now that looks like magic.
1 minute. Why do we get this blue color, bluish color, after 60 seconds or lapse of time? If solution concentrations are more, you get a lesser time, reaction is
There
faster.
it is again. Blue color has come again.
Yeah,
sir.
yeah.
So you see students, the beauty of this one reaction, we are making the color disappear, come back again, disappear, come back again. To an outsider, to a person who doesn't know science, it will look like magic. Now I can say I'm putting my power into this and I'm getting the color. And all that. In fact, if you measure the concentrations very, very accurately, you can actually predict when the color will change. So, the blue color has come. Sir, will you please explain?
Yeah, I'll do
why?
that. We'll do it in smaller steps, like what is happening at each stage. Now take just persulfate and iodide.
All right. Shall I remove this?
Just keep it in the side.
I'll remove it and put it here.
Yeah.
I will put one more beaker here. And now,
You can take it in test tubes, smaller test tubes.
smaller test tube. All right.
We just add directly persulfate and iodide. Remember earlier, iodide was the last solution to be added because there is a direct reaction between this.
I'm just adding a small quantity. Or shall I add some more?
Yes, add some more. That's it. And to that you add directly iodide.
If I add iodide directly to this,
Right, that's it. You see,
I expect there will be an immediate color change.
yeah, an immediate color change slowly and then it becomes more and more intense.
Right. Clear, sir?
See, these two are initially colorless almost. Now what's happening?
Now we will see what happens over here.
That's it. Iodine color.
You can see
Right.
the formation of a yellow color, which is slowly becoming more and more intense.
The
And
first reaction is potassium persulfate plus iodide gives you iodine plus other ions. This iodine is the one which is responsible for our observation of this. Now to this you add starch.
I'll add 1 drop of starch into it.
Typical starch iodine complex.
You see, there's an intense dark blue colored complex being formed over here.
Now you add hypo to this.
Now I will add hypo to this.
Color doesn't disappear. Okay, what you do is put.
Wait, I'll take a glass rod and mix it. You can see it is already disappearing. There it is.
The reaction between hypo with iodine is removal of iodine and you get a colorless solution. So, what the first step was potassium persulfate and iodide react to give iodine in a slow step. But you have already added some hypo in this reaction mixture. That hypo reacts first with iodine, right? But since it is a small quantity and low concentration, remember you said m by 200 of hypo, the quantity of hypo is totally consumed. Once it is consumed, the next production of iodine will be a beautiful color. That is the background.
So let me summarize this
do
for
that.
our students. There we can see the formation of that blue color again, you can see over here.
That means hypo is over.
Yes. So now just let me summarize what Professor has said. This reaction has got 2 steps. The first one is a reaction between persulfate and iodide.
Fine.
It produces iodine in a slow manner. When the iodine is being produced, to stop the iodine from reacting with the starch which we had added in the earlier reaction over here, what you saw is that the color, blue color, did not come immediately but came after 1 minute. The reason is hypo has got the tendency of holding on to the iodine much faster than the starch. So it takes a little time. But what we have done is that we have taken a very dilute solution of hypo so that it gets consumed quickly. Once it is consumed, then the iodine is free to react with the starch and get a blue color. Now again I can add some hypo into this, and again it will disappear. Again, when all the hypo has been utilized, again the color will come, and this can go on for some time. Not infinitely, but until the solution concentrations are there.
Now, one or two things important here. It's a simple setup to note the timing and do a systematic study. You can change the temperature, keep these reactants in test tube and in hot water, and repeat this experiment. So, effect of temperature is to enhance the rate of a reaction, increase the rate of a reaction, it goes faster, right? That can be studied as an extension. Number two, effect of catalyst, right? Best catalyst for this is copper sulfate. The copper +2 ions are capable of bringing this iodide a negative charge or sulfate a negative charge, and by in between we have this copper +2+. So that enhances the rate of a reaction, showing the effect of catalyst. Number three is effect of concentration. One simple variation can be, you have taken almost half test tube of potassium iodide. So in the next experiment, take 1/4 of potassium iodide and add 1/4 water. Total volume is the same, but the concentration is half of it.
That's right.
So you will see some interesting results. Concentration enhances the rate of reaction. More concentration of hypo and all that, we can get it in 25 seconds, 10 seconds. 61 seconds is not a standard one. We can make it faster or slower. And this simple clock device, known as clock reaction, we can have so many aspects studied of basic and chemical kinetics.
So let me summarize all this, students. A very simple summary is that the clock reaction is a fascinating reaction. The end point is a beautiful production of color. It's not necessarily blue. In our case it was blue, but it can be different colors for different reactions. We can study 3 or 4 aspects of the clock reaction. One is effect of concentration. If you use more of these solutions, the reactions will be faster. If you use more of hypo, the reaction will be slower. So this is one aspect. Second aspect is temperature. Every chemical reaction is affected by temperature. If you change the temperature by 10 degrees, the reaction can go double the rate. That means it can become twice faster. And the third one is you can add catalyst. In this case, as Professor has said, if we use copper as a catalyst, the reaction, instead of going for 61 seconds, will go for only 20 or 30 seconds. So a catalyst always speeds up a reaction. So you see, students, this is such a lovely experiment. You can learn so much of chemistry with just a few simple chemicals. So Professor, I thank you very much for this very fascinating
hope the students enjoyed it.
And I hope students that you have enjoyed this, and let us give him a big hand.
Okay. Thank you so much. Thank you.